Okay, working now on problem 13.6, C8H17NO. So we do our IHD analysis and we see that we have 1 unit of unsaturation for this compound, and all of the hydrogens are on carbon atoms. We'll also note that we have symmetry in this compound. Inspecting the carbon NMR, we see the peaks at 41 and 12 are both doubled, and that tells us that we've got an element of symmetry in the compound. Looking then across this methyl group here, we have a doubling in the methyl group. We see here there's a corresponding peak at 1.02 ppm, which is a triplet, which is equal to 6 hydrogens. So that's something for us to bear in mind. We can also see that we've got a triplet. Triplet means it has 2 hydrogens attached to it, and we do have a peak that is appearing as a quartet with the corresponding coupling constant to this triplet at 1.02. Okay, so then moving along, we can look at some of the features of our spectrum, and starting at the top, we have a peak at 208 ppm. Remember, we don't have a so we're sort of at a point where we're looking at our carbonyl and deciding whether or not we have an amide or a ketone, and a 208 definitely means that we have a ketone. So we're going to draw that substructure in. Because we have a ketone, that must mean that we have an amine for our nitrogen, because we only have 1 oxygen in the molecule. Okay, so we're going to take a guess at this point that the symmetry, because an amine has the opportunity to put to place 2 identical groups on it, that we could use that as a basis for our symmetry in the molecule. So drawing this out, looking at amine chemical shifts, we would expect chemical shift in the 40s for a methylene group. That seems pretty consistent with our peak here at 42 ppm, which is a triplet, and then we have a peak at 12 ppm, which again looks more or less in line with what we see from our tables. And so we can go ahead and make a guess that the peak at 41 is going to be the methylene next to the nitrogen, and the methyl group is going to be attached there. And then from here, we could fill in that this peak at 1.02 ppm, which is a triplet where 6 hydrogens, because of the symmetry, is J-coupled to the methylene at 2.52, which appears as a quartet with a coupling constant of 7.1 hertz. Okay, so that looks pretty good so far. And then we are left with our other pieces to plug in. Okay, so we have a methyl group that we need to put in, and we see that this methyl group is appearing as a singlet at 2.1 ppm. Okay, so that is not really on this table, is it? But that methyl group, that methyl ketone group, if we go to this table, we can see that a methyl ketone would be expected to come at about 2.1 ppm. So our observation of this at 2.16 ppm is correct. Then we also see that the methyl group coming at 30 would be something that we would be consistent with a methyl ketone from carbon NMR. Okay, so we're going to say that we got a methyl group here, and then just 2 methylenes to plug in between the nitrogen. So we have one end group with the methyl ketone, another end group with the amine, then just 2 methyl groups to methylenes to plug in between. So we can do that with peaks at 47.5 and 46.9, both triplets in the carbon NMR that are intervening, and then at 2.61 and 2.75 we have triplets in the proton NMR, J coupled with a coupling constant of 7.6 hertz. So here's your final answer for this one.